KI tut viele Dinge, die Menschen
AI does lots of things that people have always done, but it always does them quite differently from the way we usually do, and ideally reaches similar conclusions. That's why we do it.
Wenn wir einfach einen künstlichen Menschen nachbauen würden, hätten wir keinen Vorteil.
There would be no advantage to just creating an artificial human. We would just have what we've got now. If a human was the best solution to a problem, we would put a human there.
Das heißt, wir nutzen KI genau deswegen, weil sie anders funktioniert als Menschen.
Which means we use AI precisely because it functions differently from humans.
AI and us.
KI
AI and us.
und wir.
KI und wir.
What artificial intelligence
Means for our lives.
Was künstliche Intelligenz
means for our lives.
Was künstliche Intelligenz für unser Leben bedeutet.
An Alexander von Humboldt Foundation Science
Podcast.
Ein Wissenschaftspodcast
Der Alexander von Humboldt-Stiftung.
Episode 5. How does AI think?
Essentially, modern AIs are based on our brains. Neurons that are connected with one another in our brains, and sometimes fire and sometimes don't, are reproduced as digital neurons. Different neurons respond to different stimuli.
And these different neurons simply have one thing in common with the brain: they have a connection to other neurons. And this connection can fire or not, depending on how much input it gets. So this one neuron is firing to the next neuron according to a mathematical formula that tries to implement what our brain is doing between the different neurons.
Humboldtian Christian Becker-Asano.
To model the human mind, right? That's the traditional motivation of AI researchers.
But what does the brain do? What do the neurons do? They try to interpret signals from our sensory cells, says Humboldtian Martin Butz, professor of computer science and psychology and cognitive modeling at the University of Tübingen.
Our brain is a very generative predictive system. Essentially, its internal activities predict or try to explain away the sensory impressions that we perceive. So our brain is a generative system. That means it builds internal models of stuff of the outside world that's deemed relevant for our own behavior. And this is the biggest difference maybe from brains and current mainstream AI systems.
An AI has no understanding of the world. It can't comprehend whether something makes sense or not.
Although I have to be a little bit careful because the development is immensely fast and the big labs with the largest computer power certainly also work in this direction of giving AI even more intelligence, making it more clever, more comprehending the real world. And to do this, you essentially have to include this kind of predictive generative processes in order to develop kind of explanatory structures of the sensory information that you're perceiving.
Even if artificial intelligence could function rather like human intelligence at some stage, if it could perceive the world as we do, something crucial would probably still be missing: an emotional relationship to whatever it perceives. Tobias Matzner.
Ein Algorithmus, der ein Bild anguckt, sieht einfach nur eine Reihe von Pixeln.
An algorithm that looks at an image simply sees a row of pixels and the next row of pixels. And for the algorithm, all the potential rows of pixels, all the colors, are equally image, irrespective of whether it's noisy, whether your partner is pictured or a dog or just something blurry where it's not really so clear.
Wir haben sofort ganz viele Vorstellungen davon, ob das ein Gemälde ist.
We immediately have plenty of ideas about whether it's an oil painting or a photo. So you see, images are a whole load of things to people, but to algorithms, all images are rows of pixels. That's all.
The basic question is to which extent we want to replicate a human. I mean, you can't teach an AI to go to a restaurant and enjoy a nice meal. or to enjoy staying in bed on Sunday morning. But maybe that's not necessary.
But Milica Gašić definitely wants to make artificial intelligence somewhat more human. For example, the way AI learns. At present, the systems need far more examples than humans do before they learn something new.
This actually is all very, very limiting for us. And this is something that we try to bridge, basically, to make these algorithms learn a little more similar like humans do. And for that, we get inspired by how animals or how children, for example, learn and produce systems that imitate that to a certain extent.
This is the subject of the Sofia Kowalewskaya Award winners' research at Heinrich Heine University, Düsseldorf.
I would like to be able to build a system that can evolve over time, just like humans do. Watching my little girl growing up and learning things every day, that's really fantastic to just have that ability to, over time, acquire new things and use them.
Above all, she wants to improve language systems so that we can communicate with an AI just as we do with a person, a huge challenge.
Dialogue is one of the most natural ways for humans to exchange information, and it's really phenomenal how well we can do that.
To be or not to be? That is the question.
You can read a piece of text and you're instantly able to talk about that.
What is Hamlet actually expressing at this point?
His fear of death?
Well, no, I think it's more his inner turmoil.
Also, you can tell me what's happened to you 20 years ago and so on.
I can still remember the Hamlet I saw in Zurich. You could really feel with him. The actor conveyed the full depth of emotion. It was incredible. I wish I could remember his name.
We really are able to use language in this very wonderful way to talk to each other. Now, machines, on the other hand, they can store huge amounts of information.
In 2001, Hamlet was directed in Zurich by Christoph Schlingensief.
We can't even imagine how much information they can store. But the way they interact with us, it's very non-human.
Sorry, I didn't understand that.
So I want to equip the machines to be able to communicate with people using that same medium.
But before we can hold genuine conversations with machines, they have to acquire more than just an elegant use of language. The machines will have to become a bit more human on another level too.
We should not forget what is actually the hallmark of human-like conversation. And that, to a great extent, are emotions and the ability to recognize emotions and do something with them.
Scientists certainly try to instill feelings into robots, for instance. If robots could feel pain, they would probably treat humans more sensitively. If they could experience thirst or hunger, if they would have a survival instinct, they would perhaps navigate the world differently. Whether this is necessary and meaningful is open to debate. What Milica Gašić wants to achieve,
being able to detect user emotion, is really important. It can help the system realize whether it's doing well or not, but it can also help the system understand what the problem is and possibly even provide a better response to the user. So this is one other thing that we are actively looking at, how to enrich the dialogue with this information about emotions from the user.
As we look to the future, AI will work together with us ever more closely. When it can interpret the signals people are sending properly, perhaps really understand people, that is bound to improve our cooperation with artificial intelligence. But can we trust AI as a partner?
I'm actually quite confident that we will be able to use AI in a very responsible fashion in healthcare.
In the next episode, can we rely on AI?
This was episode 5 of AI and Us, a science podcast by the Alexander von Humboldt Foundation. The experts in this episode were Christian Becker-Asano, Professor for Artificial Intelligence at the Hochschule der Medien in Stuttgart. Martin Butz, former Alexander von Humboldt Foundation Theodor Lunen Fellow and Professor of Computer Science, Psychology and Cognitive Systems at the University of Tübingen. Milica Gašić, Sofia Kovalevskaya Award winner and Professor of Dialogue Systems and Machine Learning at University Düsseldorf. And Tobias Matzner, Professor in the Department of Media, Algorithms and Society at Paderborn University.